Hello guys, welcome. In today's video, I'm going to share a few tips with you regarding CAD design and 3D printing. This is not the latest version of my project, but this was the last time that I've used A2 Plus to simulate the movement of the wings and all the moving parts to just have an idea. And the interesting thing with that is it allows you to know if something is wrong before printing. So by doing that, you save time and even money on the filament. So right here, I'm just gonna do it in a very basic way. You can see if I move this part like that and I refresh, you would see that with all the constraints that I have here, the part is just moving accordingly to that. And this is the reason why here, for example, I removed a little bit of material because of this molder here. And I can also do that with the other parts. No matter what software you're using, here I'm using FreeCAD, but you can do that with SolidWorks, CATIA, whatever. And I would say that uh, doing this kind of simulation is very helpful in that regard of not, I would say, waste time, and you rather spend some time here creating all those constraints and simulating the whole thing, and then from there you can print something that's already good. Of course, there is always going to be some adjustments and prototypes of prototypes, but at least by doing this, you will save some valuable time. Something else that you'll find interesting is the gear here that I'm using to create this cavity here to mount on my servo. So this is just fine tuning, and the best results that I had were this one. So I'm using 21 teeth with a module of 0.224 millimeter, and the height of this cut is 4 millimeter. And the default pressure angle is 20 degrees, but I had the best results by increasing that a little bit to 25. And the first time that you will, I mean, if you want to use that, the first time that you will have to mount that on the motor, you have to put a lot of force to create a slight deformation so that it can fit correctly. And the next time you won't have to do all that. It's gonna be easier to put. And the thing is, this is technically slightly, if you can see, by the way, I took the model of the motor on GrabCAD. So if you look at this, you'll see that it's slightly smaller than this. And this is what you want, because if it's already exactly the same size, in reality, it's going to be a little loose. And the thing is, if you assemble all these parts, you have gravity pulling down in this direction. And if this is not well mounted, it's going to fall. And all those parts are like that. So this is really what gave me the best result for the little servos. And for, okay, here I don't have it, but for the MG 995, the big servo, I have the the depth or the height here is going to be 5 millimeter, and this is the module 0234. But here I kept the classic 20-degree pressure angle. You can try that and make the necessary adjustments that you need. If we come here in KiCad, we can export our PCB as a step file. So I'm just going to place that in the same folder as my mechanical parts. Here I can import my step file. So here's my PCB. Now for the colors and everything, honestly, I don't know how to make them appear, but this is not really important for me. So, um, but overall, this allows you to see how you can mount your PCB inside the body. You see, you can place that wherever you want and see if you have enough space for the board and these kind of things. For those who are interested, you have the step files on my grab card. The link is in the description. For the non-printable parts, you will need screws, ball bearing, and some magnets. So for the screws, you will need M3 16mm screws, 5 of them. So you place one here to fix this shaft with this part, 2, 3, 4, and then the last M3 that you need will be here. So this one is not useful because I created this by using a symmetrical function. So the only part that I wanted was this. So it will be 1, 2, 3, 4, and 5. And you also need, the little screws that come, the M2 screws that come with the servos to fix this. So here you need one to fix this and one here and one to fix the motor. So on this side 3, the other side you also need 3 as well. And here for this motor you also need 1, so it will be a total of 7 screws for this. These holes are there to mount magnets. I just glue them. I'm using Neodyme magnets, which are quite powerful. So I have 2 here, and I also have 2 on my bracelets that I wear, and the clips which with each other, and it allows me to lift the whole thing. And here you will need a ball bearing for to have a smooth rotation of the upper part of the system. You also have, this is some extra stuff. Here's the push button. I have this small push button to just reset the microcontroller. And on this side, I have a switch that allows me to turn on the entire device. Mounting this screw is going to be a little difficult because you have this motor that gets in the way. When it comes to 3D printing, the major tip that I can give you is level your bed correctly. This will solve 80% of all your problems. Okay, now let's have a look at my custom Cora profile. So I really went from the standard quality, so here 02, but here I increased the initial layer height. It's a little counterintuitive, but when you increase that, you have less material deposit on your first layer. You know, there's this problem that they usually call elephant foot when you have this extra material on the first layer, and you know it's not looking very good. The value here should be higher than this one. And I don't think, as far as I remember, I didn't change this here as well. I usually stay at 20 for the density, but if I have to, and I did at some point for some specific things, had to make the part a little more robust, usually I go up to 40. For the temperature, usually between 200 and 215. This is the maximum I go. I don't usually need to go that far, and that's even when I'm using PLA Plus or PLA Silk. For classic PLA, I'm at 200. It does fantastic job already. So, and for the plate, between 50 and 55. Now the print speed, I've seen in a lot of forums that you shouldn't go above 60 and these kind of things. But I have my colleague who is very much into 3D printing, and he's a perfectionist. And he told me that he doesn't care, he just increases the speed and he has good results. So I tried and I'm not disappointed. So you can definitely increase that speed. Here I'm at 90. Now, there is a correlation between the print speed and the travel speed. So, mm, when it comes to the travel speed, you will want the travel speed to be something like twice the value, or something around twice the value of the print speed. Because if it's printing very fast, but the travel speed is, let's say, even just at the same value, you have this phenomenon called stinging, when you have these lines of filaments, like some kind of spider net, you know, this kind of things. So when you increase this at around twice the speed of this one, you don't have this issue. Everything is working fine. So when I was at 55, I think here I was at something like 100. And for the support speed, that's not important, so I go up to 120. I enable retraction. Now for the support, I have two kinds of support. Depending on what I'm printing, I may use the normal, the regular one, or trees. So the trees is more like the branches. Yes, something else also about the support is the support density. I didn't always use the best filaments out there. So for some filaments, when you are printing the support, it is as hard as the part itself. And when you want to remove that, sadly, you usually end up breaking the part. And it's very frustrating to have something that was printing for hours and hours, and then once you want to remove the support, you end up breaking it. So I've tried things to lower it, so I cannot go lower than zero. And I tried that, and when I'm printing at 0% density for the support, it's perfect. Like the support is doing its job of supporting, there is no problem at all, and it is becomes very easy to remove, even with the worst filaments that I have used. So, I mean, you can try that for yourself and see, but I'm really satisfied with the support being at a density of 0%. Depending on what I'm doing, I'm either using no plate adhesion or I'm using a raft. And the raft is really when I want to assemble parts together. Let's say I have some part that I have a shaft and I have something else that I want to assemble. And when I'm not using a raft, I struggle a lot to make those parts fit correctly. But with a raft, things are very smooth. I also use a raft when I'm printing very small parts, like let's say I have a 3 millimeter uh, shaft that I'm printing. So it's so small that I will have some adhesion problems. It may fall. So when I'm using a raft, I'm making sure that I have this extra adhesion that I need. So this is it for the video. I hope that you've learned a few things.